This is 1.1.3 practice problems from POE. First thing we're going to do is going to go over some of the previous equations. So that we're going to need for this, what is the IMA equation? And what else is it? Alright. And then AMA. Force resistance over force effort. Efficiency. AMA divided by IMA times 100%. And then gear ratio, there's a bunch of them. What are some of them? That's number of teeth out over number of teeth in. We've got diameter out or diameter in, radius out over radius in. We've got angular velocity in over angular velocity out, and torque out over torque in. Everybody remember those? So this is our first problem. We have this long gear train with two levers attached at the end. So we're looking for the gear ratio and the overall IMA of the system. So let's look at the gear ratio first. So in the diagram above, A is the driver gear, so we're kind of going that way. So for we're going to find the gear ratio of what two things to get the total gear ratio of the system? A and B and CD. So we're going to say gear ratio of AB is going to be teeth out over teeth in. What is the teeth out? Yep, so 13. And teeth in? 39. So what's that end up equaling? 1/3 or 0.33, we'll say, for the gear ratio of AB. And then for gear ratio CD, what is our out teeth? 15. And the input teeth? 26. And what's that equal? It's not going to be quite so. 0.58. And for our gear ratio total, multiply those two numbers together, so 0.33 times 0.58, and what do we end up with? I say 0.19. So that's our overall gear ratio. So that's the answer to question A. Alright, I'm going to shrink that down a little bit. Alright, so for B, what is the overall IMA of the system? We need to figure out all the simple machines we have here. So what are some of the simple machines we've got? We've got two levers that are like here and here. And those can be, you can think of those as wheel and axles or pulleys. Or wheels and axles or levers, not pulleys. And then we've got another wheel and axle here. So again, we're going that way. So we're going to have to find the IMA of three different things, and then multiply those together. This is part B. Alright, so let's start. Let's say this is part 1, 2, and 3. Alright, so for 1, IMA equals effort distance over resistance distance. So what is our effort distance going to be here for 1? Where is the effort being applied, do you think? It's being applied at the end of L1, so what's our effort distance going to be? 24 inches. What is our resistance distance going to be? That's the diameter of the wheel. What did we use? We used the radius here, so we have to use the radius here as well. So it's going to be what? 19.5 divided by 2, right? So that's going to be, what is that? 8.75? No, 9.75. Everybody understand why that's 9.75 instead of 19.5? And again, we use the radius for L1, so we have to use the radius for the wheel as well. So what's that equal when we do that? Two point what? That's our IMA for part 1. For part 2, all right, which is going to be our effort distance for part 2, the gear C or gear B? B. So it goes from A to B and then from B to C. So for part 2, B is the effort, C is the resistance. So what is our effort distance for B going to be? We could use 3.25 and do the radius for both, or you can do the diameter for both. All that matters for these is that for each individual step, you either use the radius for both of them or the diameter for both of them. Does that make sense? So we can do 6.5 for our effort distance, and what would our resistance distance be then? 13. So again, as long as you're using either both radiuses or both diameters, it works out fine. So that's the answer for this one. And then 3. Alright, so now for this one, we're going to have to use the, so we've got the radius for L2, so can we use the diameter or radius for D? Radius. So what is our effort distance going to be here? That is our resistance distance, is 22.8. 3.75, so half of 7.5. Over 22.8. And what's that equal? Something tiny. Alright, so now for our IMA total, we get 2.46 times 0.5 times 0.16. And what's that end up equaling? So that's our answer to part B, is 0.20. And these two are close, but they're not they sometimes want to be in the same thing, but they don't have to be close or the same thing. Any questions on that one? First thing about this problem is that this pulley should be straight up, not over like that. Because if it's at an angle like that, it ends up changing the mechanical advantage. Alright, the compound machine above consists of a pulley combined with a lever. The load is 3.5 inches from the fulcrum. So this would be 3.5 inches. And the pulley lifts the lever 8.8 inches from the fulcrum. What is the ideal mechanical advantage? So we have a pulley and a fulcrum. Let's do pulley first. What's the IMA of that pulley going to be? How many strings are supporting the load? 2. So IMA of the pulley is 2. What class of lever is that? Second. So IMA of the lever is going to be effort distance over resistance distance. What's our effort distance? 8.8 inches. What's our resistance distance? 3.5 inches. And what's the IMA for that one? So now IMA total equals 2 times 2.51, and we get for our total IMA is going to be what? 5.02. Any questions on that one? This one's a little more complicated. So we're going to have a bunch of different simple machines. So you're applying an effort force up here. As lifting that pulley, just lifting that pulley, lift that lever. You know, we push that one down, we'll just figure out the whole thing. We're end up pushing that down instead of up. So, all right. So, what are all of our simple machines here? We've got a pulley there, pulley there. Those are two separate pulleys because they're attached at two different places. Two levers. So we got a first class lever there, and this is a second class lever here. So let's do the pulleys first. So pulley 1 and 2. What's the IMA of both of those going to be? 2. Everybody understand how we got that? Call that lever 1 and lever 2. Alright, what's the IMA of lever 1 going to be? What's our what's our effort distance? 18. What's our resistance distance? So our IMA is going to equal 3. Lever 2. What is our resistance distance, or what's our effort distance in lever 2? 14. What's our resistance distance? And so what does that end up being for our IMA for lever 2? 0.75. So now for our IMA total, we get 2 times 2 times 3 times 1.75. And what's that end up equaling? What? 21. Alright, any questions on that one?